Assalamu alaikum. Hello, my dear students. Today we'll complete our first lesson, physics, inshallah. Physical measurements. Last session, we have talked about the type of physical quantity. We have fundamental physical quantities and the derived physical quantity. Okay? Fundamental physical quantity is a basic physical quantity which can't be defined in other physical quantities. Okay? Like what? Like mass and length and time. Like what, Shabab? Mass and length and time. They are physical quantities that can't be defined in terms of another physical quantity. So, second type, derived physical quantities. They are physical quantities which can be defined. Like what? Like velocity, like acceleration, like area, like volume. Okay. Measuring tools. In ancient times, man used his arms in measurement and foot. Okay. After technological application and the new century, measuring tools are developed, okay, until we reach to the digital thermometer like this, which can read the temperature by the thermal radiation of the body, okay. Right. We'll talk about lens, measuring tools, meter tape and ruler, and the vernier caliper and the micrometer. We have four measuring tools for lens. First one, measuring tape or graduated tape used for measuring large lengths like the length of your room, and ruler to measure the length of your pencil. Okay, vernier caliper used in measuring small lengths with very high accuracy. Length of what? Length of sphere or the diameter of pen. Type micrometer used in measuring very small lengths with very high accuracy, like the thickness of what? Of wire or thickness of paper. It is very, very small measurements. Okay, so we have four measuring tools. We must know the use of each of them or the importance of each of them. طيب, Werner caliper. How can we measure the diameter of the sphere? If we have a sphere like this or cylinder, iron cylinder, okay, put it in between the two edges of the Werner caliper, تمام? And the reading of length will equal x capital plus x small. What does it mean, x capital? X capital, the reading of the fixed scale or the large scale, fixed scale or large scale. It measured in millimeter, measured in millimeter. Okay, the large scale from 0 to 1 until 0 to 1, 10 millimeter, 20 millimeter, 30 millimeter? No, because the reading or the zero of the variable scale here is before 3, before 3. يعني the diameter of the cylinder less than 30 millimeter, less than 30 millimeter. So our reading will be equal 29 millimeter. And what? 29 millimeter and point this x small. Okay? That's what شباب x small. Okay? You will have x capital and x small. X capital from the fixed scale. From what? Fixed scale. طيب, x small from the variable scale, which read with point 1, point 2, point 3, point 5. طيب, the reading of variable scale, we choose the most two identical edges or most two identical marks. Look at this zoom in, 6, not 6. Why? The two marks are not identical, but at 7 they are more identical. They are what? More identical. We have an example here using the opposite figure. The external diameter of the ball equal what? look at the zoom in the first circle, huh? Before 30 or before a 30 يبقى 29 millimeter 29 ايه millimeter. Why? Zero of the variable scale huh, doesn't reach to the 3 marks. So it will be 29. 29 point what? Huh? Look at the variable scale which of these marks are most identical. Are what? Most identical. Huh? يبقى 29 point what? 0.6. Okay. Right. So our reading will be 29.6 millimeter. Okay. طيب what about the mass? Mass measuring tools, Roman balance or two-band balance, one arm with pointer, digital balance. Digital A balance. طب Roman balance used in ancient times, used to measure the mass of the sack of potatoes, تمام, for very large masses. Okay. طيب two-band balance used for vegetables and fruits. Okay. One-band balance, vegetables and fruits. Okay. It is one band with pointer, one band with a with pointer. Digital scale used for very small masses such as a gold and silver. Okay. Sensitive. Time. The measuring tools of time in the ancient times, it is hourglass. Okay. Type, which the sand flows from the upper to the lower and so on. Okay. Type, it takes a certain time according to the design shape. Pendulum clock, it depends on the measuring time of the energy conservation when the pendulum moves from left to right and from right to left and so on. Okay. To watch, it is used in to measure the certain time of competition or a race or and so on. Digital watch used in our daily life. Okay. Measuring units. Okay. Measuring units. But today we have talked about the physical quantities and the measuring tools of each one, mass and length and time. Okay. Right. Measuring units in ancient times, each country has its own measuring units. We have to study systems from these measuring units. French system and British system and the metric system. French system use centimeter for measuring the length and the gram and the second. So French system could Gaussian system and CGS system. CGS centimeter gram second. Centimeter a gram second. طب the British system FBS. What does it mean FBS? Foot for length, pound for mass, time for second. Second for times. طب metric system MKS meter, kilogram and second. Meter, kilogram A and second. Okay. When we measure the length of pencil or the mass of object, we must determine the magnitude and the measuring unit tool, measuring unit used. Okay. If I ask someone to measure the length of your pencil, the length of pencil equal what? Equal 10 centimeter. Okay, so the magnitude equal 10 and the unit equal centimeter. Okay, so this this is false. Why? There is no measuring unit, and this is true. Huh? The following is the mass of the body equal 5 kilogram. It is true. Magnitude and the measuring unit. We have to study the international system units or SI units. Okay, this unit is applied all over the country, all over the world. Okay, called what? SI units, international system units. Right. They are 7 physical quantities, and there are 2 units are added to them. All of them are 9. First, length measured by meter, mass, kilogram, time. Second, electric current intensity ampere, absolute temperature Kelvin, degree, amount of substance mole, اللي هو number of substance أو amount of substance equal mole, luminous intensity اللي هي شدة الإضاءة for the electric lamps are measured by a candela, plane angle measured by radian, solid angle measured by a steradian. Okay. SI units are applied for all physical quantities. How, Mr. Volume measured by cubic meter. Where is cubic meter here, Mr.? Volume means length times width times height. Okay, شباب؟ طيب. So volume equal length times E times width times height. Okay. Right. So length measured by meter and width measured by meter and height measured by meter, all of them measured by meter. So volume related to the SI units and velocity equal displacement over time. Displacement means or measured by meter and time measured by second. Meter here and second is also here. Okay. Type. Standard units. Okay. We have to study standard meter and standard kilogram and standard second. What's meant by standard meter or the standard measuring unit of length of SI units? A standard meter is the distance between two engraved marks. Okay, we have a rod made up of what? Two metals, platinum and iridium alloy. Platinum and the iridium alloy. There are two metals which are chemically inactive. They doesn't affecting by the temperature of the environment or doesn't expand or contract. Okay. The standard meter is the distance between two engraved marks. Between what? Two engraved marks on the platinum and the iridium alloy. تمام؟ طيب. They are kept at 0 Celsius degree at the International Bureau of Weights and Measures near Paris. تمام؟ So the standard meter are kept at a 0 Celsius degree and it is made up of what? Of platinum and iridium alloy. تمام؟ And we also have the standard kilogram. It is the mass of platinum and iridium alloy, okay, kept at a 0 Celsius degree near Paris. Type. Why, Mr. The standard meter and the standard kilogram are made up of platinum and iridium alloy? Because platinum and iridium alloy are rigid and chemically inactive, not affected, and chemically inactive, and also not affected by the environment. Okay. Contrary to the other material. So standard kilogram is the mass of the cylinder made up of platinum and iridium alloy kept at 0 Celsius degree at the International Bureau of Weights and Measure near Paris. So the standard second. In ancient times, daytime and nighttime were taken an easy and acceptable measure of the time of the day. Solar day equal 24 hours. 1 hour or each hour contains 60 minutes and minute contains 60 seconds. Okay, right. So if you want to calculate the number of seconds or how many seconds in 1 year equal 24 times 60 times 60 to get the number of seconds in over the year. Okay, right. Recently, scientists use atomic clocks such as cesium. Cesium is a radioactive element which emits types of wavelengths or type of waves. Okay, type. It's used to calibrate the second because of their high accuracy. What does it mean, calibrate? Calibrate means take a standard, okay, and return to it every time. or every year. Like what? Like the standard kilogram. Standard kilogram must be if you if you uh, if you want to get vegetables or fruits, huh, from sorry, as the shops of vegetables and fruits, we have to see some standard mass like a cylinder has mass of 1 kilogram and 2 kilogram or half kilogram. Okay, this standard masses or these masses must be calibrated from one time to another. From what? One time to another. This larger one, 5 kilogram. So every 1 year or every 2 years, تمام, the grocery or the seller must calibrate this standard mass with a 1 kilogram or a 5 kilogram. Okay, why? Because it may be affected by decrease or increase from uses or from the temperature from the surrounding environment. Okay, type. Atomic cesium clock used to calibrate second, okay, to make our time is standard because of their high accuracy. What is the importance of atomic clock of cesium? Determination of the duration of the Earth's spin, the day length, تمام? When the Earth rotates around itself, okay? طيب. Tuning up the clocks used for aviation and navigation in airplanes and spaceships, تمام? Uh, we must know how to convert from these units to the unit, like what? Like nanometer or picometer or micro or tera or giga and a meg. Okay. Firstly, the unit. The unit, for example, the unit is meter. When we have a unit larger than meter, like kilometer, mega, giga, and a tera. Okay. If we arrange them in a ladder, okay, every 1 degree, you must make it times 3, 10 power 3. 10 power what? 10 power 3. From tera to giga times 10 power 3 times 10 power 3. Okay, from mega to kilo times 10 power 3. From kilo to unit equal times 10 power 3. Okay, so the first one, here's what is tera. Okay, then giga, then mega, 10 power 3. Then kilo, then يبقى زي unit. For example مثلا متر. يا شباب for example متر. Then we have fractions less than the unit like millimeter, and micrometer. You must keep it شباب ان شاء الله يعني it is very important this year and next 2 years ان شاء الله. تمام في physics. تمام طيب مايكرو نانو okay and بيكو ميتر. بيكو ايه؟ بيكو ميتر. اوكي طيب the difference between each one of this equal what? equal 10 باور 3 equal ايه يا شباب؟ 10 باور 3 يبقى تيرا and giga mega kilo and the measuring unit itself milli micro nano pico. Okay طيب to convert from tera to giga we must make it to convert from tera to giga times 10 power what? times 10 power 3. طيب from giga to mega also times 10 power what شباب؟ times 10 power 3. طب from mega to kilo also and ايه so on. The difference between each degree make times 10 power 3 until you reach to the the picometer. Okay for each degree, for each fraction from from 0. طيب we have an example here. If we have to convert the length of object equal 5 times 10 power 3 nanometer. 5 times 10 power ايه يا شباب؟ times 10 power 3 nanometer. We need to convert it into meter. Who can convert it شباب؟ To convert from nanometer to meter from nano to meter. So when we get or move from down to up, we make each degree of them times 10 power negative 3. So the difference between nano and the meter equal what? 10 times 10 power negative 3. 1 times 10 power negative 3 times 10 power negative 3 again times 10 power negative 3 again. So to convert from nanometer to meter, we must multiply it by by times by 10 times 10 power negative 9, 10 power negative 9, 10 power negative 3, 10 power negative 3, 10 power negative 3, 10 power negative 9. 5 times 10 power 3. This is the magnitude only. This what? This is the magnitude of this value times بقى the conversion of nanometer to what شباب؟ to meter times 10 power negative power negative 9. Okay equal equal what شباب؟ 5 times 10 power negative 6 meter. Okay طيب we have another example. We have a frequency of an object or a device equal 300 megahertz. 300 what? Megahertz. We need to convert it into hertz only. انتوا what شباب؟ انتوا hertz. Who can convert it؟ ها؟ If we want to convert from megahertz to hertz, hertz it is the unit itself. Okay? طيب from mega to the unit or to hertz. ها? Hertz must be written here. From mega to kilo يبقى times 10 power 3. From kilo to hertz times 10 power 3 يبقى 300 times 10 power positive 6. 300 times 10 power A power positive 6. Okay? يبقى if you want to convert from larger to smaller one, we must multiply by 10 power positive 3 between each degree. طيب from smaller to larger one, ها يبقى multiply by 10 power negative 3. 10 power negative. Okay? From larger to smaller, multiply times 10 power positive. Okay يا شباب? You must keep this. It is very important. طيب we have notes here. Liter is the measurement of volume of liquid and gas, and it is equivalent to 10 power negative 3 of cubic meter. Angstrom is the measuring unit of very small lenses like the radii or the radius of the atom. It is equivalent to 10 times 10 power negative 10. 10 power negative 10 of meter gram is the measurement of small masses, and equal 10 power negative 3 ton is the measurement of very large masses like the trucks. 10 power positive 3 of gram type. Another note, if we have two physical quantities, okay, before adding or subtract them, we must convert it into the same unit. So we can't write 1 meter plus 170 centimeters. Why? Because both of them must be in the same unit, in meter or in centimeter. So we must convert one of them to the measuring unit of the other. 1 meter plus 1.7 meter equal 2.7 meter. طيب 100 centimeter plus 107 centimeter equal 270 centimeter. Okay. enrichment information بينا الباوند equal half kilogram, 1 foot equal 0.3 approximately equal 30 سنتيمتر يعني تمام كده. طيب to convert from mile to yard and from yard to foot and from foot to inch, we must multiply 1 mile by 1760 from yard to foot equal times 3 and the foot times 12 to reach to the inch. Okay, so 1 foot equal 12 inch, 1 yard equal 3 foot, 1 mile equal 1760 yards. Okay, if you have a problem like this 5 kilometer, to convert it into millimeter, we must convert it into meter firstly and convert from meter to milli. Okay. What about this? This is the measuring unit of volume. Measuring unit of what? Volume. 3 centimeter cubic. To convert it into kilometer cubic, we must convert it into a meter cubic firstly. 3 times 10 power negative 6. And convert it into a kilometer times 10 power negative 9. All of them 10 power negative 10 power negative 15. طيب The measurement of the speed is kilometer per hour and meter per second. To convert from kilometer per hour to meter per second, we must divide it by 3.6. By ايه يا شباب؟ by 3.6. As we have studied in the last year. Okay? We have a new point in this lesson, dimensional formula. Dimensional formula. Dimensional formula is a formula that used to verify the mathematical equations or the laws used in physics. Again, what is the importance of dimension formula? Okay, it is a formula used to verify the correction or the mistakes used in physical laws, okay, or any mathematical relation. Okay, we will study it in details inshallah next session. تمام. But dimension formula is mass and length at time. Any physical quantity must be written in the three-dimensional MLT. MLT. Okay? طيب. The physical quantity written in between the two brackets in this shape, the physical quantity written here, and MLT, each one of them has its own power. Each one of them has its own power. Okay? طيب. How to get the dimension formula of any physical quantities? We must write the mathematical relation velocity equal displacement over time. V equal displacement over time. طيب. To get the mathematical relation, the dimension formula, V written between the two brackets like this. Okay? V هي الفيلوسيتي يعني. Okay? Equal L means displacement over over time. طيب ما هو over time means T power -1. T power -1. So the dimension formula of the velocity equal LT power -1. طب speed LT power -1. Okay. طيب acceleration هي الاكسلريشن اصلا الاكسلريشن دلتا في over دلتا تي. يبقى the dimension formula of the velocity divided time. L over T divided T يبقى LT power -2. The dimension formula of acceleration L2 power LT power -2. Okay. We have notes here. To add or subtract two physical quantities, it must have of the same kind, of the same or the same type. Okay. It can be multiplied or divided physical quantities with different dimension formula. Okay. Dimension formula can't be added or subtracted, but they can be multiplied or divided. Any constant number or pi doesn't have dimension formula, doesn't have dimension formula. Area, length times width. Length measured by meter, width measured by meter. L power 2, the dimension formula of equal L power 2. The volume, length times width times height, meter times meter times meter. L power 3. Type density, mass over the volume. Mass means M. Volume means L power -3. Take care, we can about this dimension formula. So if you want to know the measuring unit of physical quantities and you have the dimension formula, you can get it from the dimension formula. Like acceleration. L means length, a meter. T power -2 means second power -2. طيب. Density. ML power -3. كيلو جرام divided متر ايه كيوبيك، or كيلو جرام ايه متر باور ايه باور 6. يا شباب ثانك يو. لاست نيكست سيشن ان شاء الله نكمل ايه بقيه الشابتر باذن الله.